All right, so I'm here today to help you through this first lab, the continuous conducting path lab. So in the notes, it's lab 7.3, and we're going to be utilizing a simulation to do this. So if you go to the your lab, at the bottom of the first page, it says note, all circuit portions can also be made with this simulation. And that's what we're going to be doing right now. So if I open up that lab, it brings me to this PhET simulation. And right now, we can just worry about the introduction part of it. And this is pretty much it. It's very simple, but it gives us everything that we need to do with this lab. So let me go ahead and scroll down to lab 7.3. We are talking about a continuous conducting path. So the purpose is to explore the concept of current and how it pertains to continuous conducting path for electrons to flow. So we want to set up this following circuit. Right now it has a couple of batteries, it has a two light bulbs, and they just kind of flow around. So I'm going to go to my circuit kit and I'm going to do exactly that. And I'm going to put a couple of batteries. You can mess around with the orientation. And so there we go. There we go. And I'm going to just kind of connect these two together. And I'm going to do a third one, connect that one together. And boom, now it kind of moves as one. A light bulb and another light bulb. And then we use some wires to connect that all together. So it's I mean it's really not that complex of a simulation. And if I do that, oh my God, look at that! The wires allow the electrons to flow through. So we're seeing all these electrons flowing through from positive to negative. Again, this is the how the convention for electricity. We know that that is a little bit not quite everything we want to talk about, but that's okay for right now. So we got electrons flowing, and it's going to go through the light bulb. It goes across the filament, and it makes the light bulbs light up. Well, that's really simple. So the point of this lab is to see how current flows and create this continuous conducting path. So in the first part, activity one, super easy. What will happen to bulbs one and two when you disconnect the wires at various points? So it says here's point A, point B, point C, point D, point E, and point F. So we're going to make a prediction as far as to what's going to happen to each bulb when I disconnect it, and observations for which happens to each bulb when I disconnect it. So make your predictions first, and then do the experiment, guys. This is not meant to be a brain buster. If I disconnect, in order to disconnect it, I click the cut tool, and what happens? Right, it's not meant to be super complex. I'll give you a hint. The name of the lab is continuous conducting path, because you have to have a continuous conducting path, right? So that's activity one. Very, very simple. Explain your predictions, explain what you can conclude. Lab activity two is a little different. Now we still have the same concept where we still have two bulbs, but I'm actually going to cut this right here. And in between that, I'm going to insert something. So on this lab, it says, what happens when you put the something between the two bulbs? And you might think, well, I can't do this on here. Well, if you go to the left hand side over here, there's a menu. And if I scroll down, look at that. I have some somethings, except my somethings here are a little different. So replace anything that you can't do with these with the ones that you can do with these over here. So here's my dollar bill. What's going to happen when I connect that dollar bill? Dollar bill, y'all. Sorry for that. I'm going to go ahead and delete that. Paperclip. What's going to happen when I connect that paperclip? Right? The coin, you can do the coin. You can do not the wire, an eraser. You can do a pencil. You can do your hand. You can do a dog. And of course, we already talked about the dollar bill and the paperclip. So instead of doing foil, cardboard, paperclip, string, wax, paper, you're going to do dollar bill, paperclip, eraser, hand, pencil, dog, coin. And all you have to do is put connect them to each side and see what happens, right? So when I let it go, what happens? Well, in that case, nothing happens. So that's That's no good. But so then you would put for does it light? Yes or no. Very simple. And that is it for lab 7.3. It's called the continuous conducting path, and it deals with making sure the path is not only continuous, meaning it has one way for electrons to flow, but also that everything in the path can conduct electricity. And that's it for lab 7.3.